Hi everyone. It's been quite some time since I did a video on my personal channel because I've been quite busy with Financial Modeling World Cup and FMWC South Africa local chapter initiatives like the South African Excel Championships. You can go and check that out at fmworldcup.com and look for the local chapters, or you can just Google the South African Excel Championships. That's been my pet project for the last couple of years and months. Um, but being that it's the 30th of September 2024 and it's Excel's 39th birthday, I thought it would be a good idea to talk to you guys about South African ID numbers and the structure around that. But essentially, that last character, that last little checksum character that uses the Luhn algorithm, how to actually build a scalable function with a lambda in order to validate an ID number. And it was just too cool of a solution for me not to share it with the community. So if we talk about the ID number structure, essentially the ID number is structured with the first six characters making up the person's birth date. And then the next four characters essentially determine or showing the sequence as well as gender. So if it's below 5,000, it would be a female, and then anything 5,000 and above would be male. The third last character would always be a 0 for a citizen and a 1 for a permanent resident. And then the second to last character will always be an 8 in very or an 8 or a 9. A 9 would only be in select cases where the sequence ran out on those SSSS numbers. Could be a 9, but a citizen can actually apply for a certificate of validity if there's a 9 in that second to last number. And then the last number would be the checksum digit, and that uses the Luhn algorithm, and I'm going to be explaining that now. So essentially what we'll be doing today is we'll be building a Luhn with a Luhn validation with the Lambda, and I'm going to be stepping through that. So if you don't want to skip to the end, this is the function. Essentially, the function is laid out here. I did use various methods in order to build that function. So I'm going to be sharing a different method, and I'm going to be taking it through step by step, and also explaining how the validation of ID numbers actually are performed or are done. So essentially, there's an article that was featured on my broadband. I think it was a year or two ago, and I've linked to it in the document as well. And this document will be available for download in the description of the video, so that you can play along with me and try it on your side as well. Just to highlight as well, I've added a formula here. It doesn't allow for checking after the year 2000, but it's just a sort of explanation of how you can derive, or just a showcase of how the birthday can be derived from the email address, the gender as well on the fourth character, the sequence on the next three characters, and then the citizenship status, or whether it's a citizen or a permanent resident. So I've included those formulas as well. And then essentially, if we want to build now the validation, I'll explain the steps as we go along. But to start doing that, we need to firstly split out the ID number into its different characters. So to do that, I'm going to use the mid function. But to start things off, if I'm working with numbers, I always start off with the double dash, and that always converts any resultant numbers into numbers if there are numbers. In this case, we expect only numbers, so I'll go double dash, and then I'll use the mid function, and that returns characters from the middle of a text string given a starting position and length. So essentially, all I'm trying to do is I'm trying to split this up into its 13 different digits. So so the starting number would actually be the sequence of all the numbers. So it would be the sequence of the number 1, 2, 3, 4, 5 up until the number 13. So for that, I'll use the sequence function, and I want to spill this into rows. sorry, into columns. So I'm going to skip rows, and then I want to return the number of rows based on this the string length, or this, yeah, the length of the string. I know that an ID number consists of 13 characters, but to build a more scalable function, we use the len function, and that returns the length. And then basically, I want to basically spill out 1 to 13. I'm going to not include the start and the step because that is in block brackets, and when it's in block brackets, I essentially it's essentially optional. So it would be start with 1 and step by 1 by default. So I'm okay with that. And then the number of characters to return at a time with every sequence would be 1 character at a time, and that will spill for me the entire ID number into 13 separate columns. Next up, and the reason why I'm showing this is basically just to show my thinking pattern. I've practiced enough so that I can write the let without necessarily following these validation steps. But if you're not comfortable with that, I always recommend building your steps out like this before you try and build it into a lambda or a let. So step 1 would be working from the rightmost digit of the number, double every second digit. So in this case, we don't have to start with the rightmost digit, because if I start from the left, it's the same. Essentially, I'm looking for every even position. So in this case, I can use the index function, because the index function will return a value or reference of the cell at the intersection of a particular row or column in a given range. So my range in this case is my array that was spilled above, and we're referring to K2 hash because that's the spilled reference from the mid formula that we used, or the mid function that we used above. In this case, I want to spill that into columns again. So, or I want to return the columns. So I'm not referring to row numbers because all of them are in one row. And in this case, I want to return the second, fourth, sixth, eighth, 10th, and 12th position of that string. And again, my sequence function would allow me to do that. I can now spill row references, but just to stay consistent with horizontal logic in one row, I'm going to skip rows. I'm going to spill a sequence of columns. And in this case, I can see that there's 6. I can see here below that there's 6 numbers between, well, essentially 2 and 12, including 2 and 12. So I'm going to spill 6 columns, start at the second value, so start at 2, and step by 2, so that it goes 2, 4, 6, 8, 10, 12. And in that case, that will basically return for me the second, fourth, sixth, 8th, 10th, and 12th character in that ID number. Next up, I want to basically double that every second digit. So basically, I'm just multiplying everything by 2. So this now, that's now step 1 done. Step 2 is basically adding the digits of this result together. So basically what I want to do now is I want to split up anything with 2 digits, add them together. So to do that, I can use the by-col function, because the by-col function applies a lambda function to each column and returns an array of the results. I'm not going to use by-col in this case because I want to make this entirely dynamic, and therefore I'm going to use the map. So the map function returns an array formed by mapping each value in the array to a new value by applying a lambda to create that new value. So basically, my array is everything that was spilled in step 1. And the lambda that I apply on this is lambda. And now my first parameter can be anything, because essentially what map does is it takes every value in that array, and it assigns it to that parameter, to that first parameter. So in this case, I can call it anything. I'm just going to call it x, so that's quick and easy to refer to. But basically, that's my parameter. So firstly, it will be 16 as x, then it will be 2 as x, etc. And the function that I'm going to be applying to that is a sum of, and again, I'm going to do a double dash to, because when I take a string, the mid function is a string function, and when I split out the numbers 1 and 6, it'll be seen as a text 1 and 6. So that double dash just does the conversion to numbers. Otherwise, my sum will be 0 because it will think that it's summing characters together. So then I go mid of, and the text would be x again, so that's 16 in the first place. The starting number would be well, again, the sequence of the length. So essentially, I need to go sequence, and in this case, sticking to columns, length of x. So in the first case, and you could just follow me up above if this is not readable anymore. So essentially, it's determining the length of x. In the first case, the length is 2 characters because it's 1 and 6, and it's basically throwing a sequence of that. So it's 1 and 2. So that's just referring to that value, and then the number of characters again 1. And that should now give me the answer. I just need another closing parentheses there. So essentially, 1 plus 6 is 7, 2 is just 2, 6 is just 6, and again, 1 plus 6 is 7 in the end. So that's doing exactly what I wanted it to do. And it does seem a bit strange and a bit difficult to understand, but it truly is not. So I guess rather just play back the video and try and understand it, because once you grasp the concept of this, it's actually very simple. Essentially, all that the map is doing is it's taking the sequence of numbers one by one, and it's applying this lambda to it. So it's firstly taking 16, and that's putting it in the value of x, and then what it's doing is it's taking the number 16 and it's determining the length of that number, so that's 2, and it's basically spelling a sequence of 2, so it's the numbers 1 and 2, and then next up it is bringing back with the mid function, it's bringing them back one by one. So just to showcase what that looks like, I'll just go mid of 16, start with the sequence of, in this case, the length of that G5. So take the length of that and then spill one character at a time, and you'll see that that takes 1 and 6. And then all that I'm doing after that is I'm doing the sum of those two, which is returning 7. And because I'm wrapping it in the map function, it basically applies that across the full array. Okay, so then step 3 is summing together the resultant digits with the remaining odd digits of the ID number. Right, so it's basically a sum, and it's taking the sum of all of those, and then it is also adding the odd numbers. So in this case, I can use the index function again, and basically referring again to my full ID that is split, I will return only the odd numbers. So I'm using the sequence function, and in this case columns again. I know that there's 7 odd numbers because we've got 13 characters. We had 6 even, 7 odd, and we want to start at the number 1 and step by 2. So basically it'll step character 1, 3, 5, 7, 9, 11, and 13, and then return those positions for me, and sum that together with the result above, and that gives me the result of 50. If we look at step 4, basically what we're doing is we are determining if that sum is divisible by 10 without a remainder, then that ID number is valid. And Excel actually has a function called mod that does exactly that. So if we look at the mod function, you'll see that the mod function returns the remainder after a number is divided by a divisor. So I'm saying take the number 50 and divide it by 10, are there any numbers left? So what it's doing is it's taking the number 50, dividing out by 10 until it can't divide by 10 anymore, and basically taking the remainder of that. In this case, we're expecting 0, and that's correct. So let me just make sure that this function is also spelled there. So that's basically what I attempted to do. And if this number was 51, for instance, just to show, then the result would be 1, because we're dividing by 10 at a time, and then there's 1 remaining. The number 1 remains. All right. So that gives me my answer, and then I could now say, is this valid? And because it's 0, it's basically the inverse of what we're trying to achieve. So if I go not mod, just to show, that'll give me the number, the value true, and basically tell me it's valid. But just to make this a little bit more pretty, I guess, for the end user, we'll just wrap this in an if function and say, if that's the case, then it's valid. Otherwise, it's invalid. And that basically gives me the answer. All right. So that means if I change this number to this last number to any number except for 8, this ID number would be considered invalid. All right. Then the next step is to write this all into one function, and we can use the let function. The let function is magical. It's one of the best things of modern Excel, or one of the best functions that exists in modern Excel. And basically, the let function allows me, and there's the description, allows me to assign a calculation result to names. It's useful for storing intermediate calculations and values by defining names inside a formula, and they only apply in the scope of that let function. So essentially, I'm going to now give stuff names. So I can now call ID this number, and then so I'm using Alt Enter to put every single sort of name or calculation on its own line, and that just makes it easier to read, easier to audit, easier to problem solve, easier to error check, or easier for error tracing. So now I need to split up the ID like I did above. So basically I'm going to say ID, I'm just going to call this ID split, and I'm just going to use that mid function again. So it's double dash of the mid of my ID in this case. So I can refer back to my ID value there, and my starting number is the sequence, not the search, the sequence of the length of ID, and that is, and then for 1 character at a time. So that's my mid. I shouldn't have pressed enter there. So that's my mid. So what I can do now is, as I'm building this, I can actually check whether my steps are working correctly by now just telling the let to bring back the ID split value and closing the let, and that'll spill the split values for me. But I could do that, so I'm not going to do that now. But essentially, that I can go back and retrace every single step and check that it's working like it should. Then next up, we'll do step 1. Step 1 is essentially the doubling of those values. So I'm just going to quickly write that out. So I'm indexing my ID split, and I am referring to the sequence of the odd columns, so the even columns. So essentially I'm going to say I need 6 columns, start at 2, step by 2, and then basically return those for me and multiply that by 2, comma, next name. Step 2 is basically now going to say, well, take those values in step 1 and map those. So I'm going to use that map function. I'm mapping step 1 and applying the lambda to it. The lambda passing the parameter x of the values of step 1. I am applying a sum to the number converted mid of x, starting with the sequence of the length of X and essentially returning one character at a time, summing that up, closing my lambda, closing my map. Next step. Step 3 is essentially now going to do that sum of the resultant values. So I'm just going to go sum of step 2. So I want to take step 2 and I want to add the index of my ID split, and I want to return the sequence of all my odds now. So I want 7 columns, starting at 1, stepping by 2, and take the sum of that. And I believe that's almost there. So step 4 is now basically just step 4 is just now checking whether it's valid or not. So I'm just going to say if not mod of step 3 and the divisor is 10, then it's valid. Otherwise, it's invalid. And hopefully I've done that correctly. And close my let. I've entered too few functions. Oh, sorry. I still need to tell let what I need to return. So basically, I'm just saying return step 4 for me. And again, there we go. So that's not right. So now, I guess it's a good thing that it's not right. So now I can actually problem solve or basically step through these. So let's ask let to return for me just step 4. So step 4 is returning a 66, which is wrong. So let's look at step 3. It's going to spill now, perhaps. So after looking at this function, I realized that I wrapped a sequence in a sequence there. So too many sequences there. So I should have just had the index of that ID, that split ID, and reference one sequence of that, multiply that by 2. If I then return step 3, I can see that that's the 50 that I was expecting. So now returning step 4 gives me the valid messaging. But that's the nice thing about the let function, is the fact that I can go and reference back to every single step in my last sort of calculation or name, and that would return for me the outcome of that specific name. So yeah, now I'm ready to wrap that into a lambda, and how I do that is I basically just copy my let function, and I go and open up, and I start off with a lambda. I just go Alt Enter, and I start off with my lambda. The parameter that I want to pass into the lambda is called ID, and I can replace that means I can remove this ID reference there. The rest of the function should work as is, and then lastly, I will just close up my lambda, and to test the lambda, I put that into normal brackets. I'll just pass in a reference or pass in that first parameter, and if I did everything correctly, I'll have a valid return from a lambda function. There's my lambda function. And then what's nice about this is the fact now that I can take this lambda function and I can make it a permanent function in my workbook, or in all future workbooks that I work in. I basically copy everything except for the final parameter that I pass, copy that, and then go into my formulas, go into name manager, create a new name, call it Luhn check, or anything that I would want to call it, and then that refers to my lambda. Click on OK, and the nice thing about this is now if I just copy this validation across, I can now go and refer to Luhn check as a function. My ID value or my ID parameter, I can now pass in an ID parameter there, and that does my whole calculation for me. And that's essentially what I wanted to share with you all today is how to do that. The nice thing about the modern Excel is the fact that it now is simple enough to create your own functions, and you can create very complex functions. This is not necessarily overly complex, but I wouldn't want to write this every time I do a future ID validation. Having this function now as simple as a name to refer to, I can now apply this anywhere I want to, and the logic is sound and it's tested, and I've got everything well documented as well. Yeah. So, like I said, the this document will be available in the in the video description below. And if you like what you saw, please like, share, and subscribe. And yeah, share it with others out there that might benefit from it as well. And then I hope to see more of you guys. I hope to also send out a couple more videos in the coming months. So watch the space and take care. Thanks.